Okay, we're going to continue our unit on exponentials and logarithms. And now we're going to get into something called the properties of logarithms. And I have 3 questions that will talk about all the different things that we can do with logarithms that kind of work out really, really neat. And then we can see some cool stuff and manipulate things using those properties. So the first thing we'll do is kind of take a crazy looking logarithm expression and then condense it, write it as a single logarithm. And then what we're going to do is take a condensed single logarithm and then expand it out as much as we can using properties of logarithms. And then we're going to use something called a change of base formula to evaluate expressions. And so all of this stuff that we can do with logarithms. And the way we're going to get into it is I'm going to use one example of something we already know and then kind of play around with this example to show what properties of logarithms actually exist. And so I'm going to start with a basic thing like this, log base 2 of 8. And we're going to figure out, well, what is that? And then from the previous lesson, we know that this thing is asking a question. It's asking, 2 to what power equals 8. And of course, we know that, of course, it's going to be 3. So we know that the log base 2 of 8 is 3. So I'm going to play around with this one example to reveal some properties of logarithms. And here's the first thing I'm going to reveal. Did you know that that 8 happens to be 4 times 2? And so we could rewrite this as the log base 2. Instead of saying 8, we'll just call it 4 times 2. And we could do something with this to show a property of logarithms. We can take the fact that 8 is the product of 2 and 4. And what we can do is write this as 2 different logarithmic expressions. We could totally break up this logarithm into 2 expressions. Okay, and then we'll show one of the properties of logarithms. Okay, so the first property that we can show is this. If I can break this up into 2, I can call it log base 2 of 2. And I can call it log base 2 of 4. And then if I add them together, I should have the same result. That's just something I can do with that logarithm. And so we know when we look at the log base 2 of 2, we know that is the number 1. 2 to what power gives us 2? 2 to the first power. And we know that this is, okay, so 2 to what power gives us 4? That the log base 2 of 4 happens to be 2. And if we add them, 1 plus 2, of course, is 3. So we know that the log base 2 of 8 is 3. And that way we can test, well, does this actually work? Why, yes, it does. It's just something we can do with logarithms. We can say if we can express our number as a product of 2 other numbers, we can break up that logarithm and add them together, and it would be the same thing. And so here comes one of the properties of logarithm. It's called a product property. Okay, so we have a property of logs. Looks something like this. If you have a log of any base, and the number you're taking the log of is the product of 2 other numbers, like 8 was the product of 2 and 4, what we can do is rewrite that logarithm as basically a sum of 2 other logarithms with the same base. Okay, so it's the sum of the logarithm. The base stays the same throughout, and we can just add those 2, and then we'd have the same thing. It's exactly what we just proved here. Okay, so if we can express 8 as 2 times 4, we can break it up into 2 logarithms, and then add them, we'd still get the same thing. So it's a property of logs. We can do that. All right, so it's one of the properties of logs that we can work with. I'm going to take that same example and show another property of logs. So we remember the log base 2 of 8. What was that again? I already forgot. 2 to what power equals 8? Oh, yeah, it's 3. Now, is there a way to show 8 instead of a product? Is there a way to show 8 as a quotient? Okay, so a division thing, right? So we have the log base 2. 8 happens to be 16 divided by 2. So we're wondering, can I rewrite that as 2 two different logarithms and still come out to be the number 3? The answer is why yes, I can. Okay, so we can take this and split it up into two different logarithms with the same base. Okay, so it's still going to be the base of 2, right? And then we'll have, well, log base 2 of 16 and log base 2 of 2. And if we subtract them, we should have the number 3. Because we know the log base 2 of 8 is 3, so if we express 8 as 16 divided by 2, we can get the same thing, right? So 2 to what power is 16? We know that's going to be 4. 2 to what power is 2? We know that's going to be 1. And if we subtract 4 and 1, of course, we're going to get 3. Yay. So that works as well. So we have just seen now in demonstration another property of logarithms. So if I have any logarithm with a base of b and it's a quotient, okay, so one number divided by another number, I can expand that. It's called expanding. Same base of the numerator minus the logarithm of the denominator. That's a property of logs. We just proved it, right? So it's totally possible. And I can get into another example that will show a whole other property of logs. This one's kind of fun. I like this one. All right, so we know that the log base 2 of 8 is 3, right? So is there another way to express 8? Isn't 8 an exponent as well? 8 is 2 to the 3rd power, right? So you know what I can do with this just to see if it works? I can take this 3 as an exponent, right? I could take that 3 as an exponent and just boom, move it out to the front and basically as kind of a coefficient for the logarithm. I can totally do that. And then call this 3 times the log base 2 of 2. That's just something that's neat that happens with logarithms. So we can do that. Let's see if that holds true. Does that hold true? Okay, so we know 3 is 3, right? Got that. And then what's the log base 2 of 2? Is 1. And 3 times 1, 3. Amazing. So that totally works as well, right? We have that property of logarithms. So we have a third property of logs. We can completely state with all accuracy that if we have log base b of some number that's actually an exponent, we'll say m to the nth power, what that means we can do is take that exponent and then move it out to the front as basically a coefficient for the logarithm. And that's the property of logs. It can totally work that way. And you know, we actually did this as an example. Remember in the previous lesson, we had this logarithm, log base 5 of 1 over 25, and we knew that was going to be -2. Now check it out, log base 5 of 1, which is 0, minus log base 5 of 25, which we know is 2. 0 minus 2, -2. Whoa, cool. Anyway, we've done that before, so we already know that these properties of logs work. With that, we are so ready now to answer problems 1 and 2. We can get to work on these and do what the problem asks. One is simplifying and the other is expanding. So let's take a look at this complicated thing here. All right, so with number 1, we got a lot of stuff that's going on. and we can basically work backwards from the properties that we have discovered, and that's what we'll do. We're going to know these properties backward and forward. Okay, so we have this setup, and what we're going to do is write that as one logarithm. Okay, so we know that we have all these properties that we've established, and what we can do is take these properties and work backward. Okay, because if they work this way, that means we can take logarithms that are written this way and then we can simplify them, and that's what we can do. So we can start messing around with that third property. Okay, see we have a 2 out in front of a log base 3 of 4. So what that means we can do is keep log base 3 of 4 and then raise it to the 2nd power, because that's what that means, right? And then we can take this 3 out in front of log base 3 of y and then make that 3 the exponent. Then everything else stays the same, right? So we could do that. And then we can start simplifying some stuff. 4 squared is 16. We can call it that. So log base 3 of 16 plus log base 3 of y cubed, and then minus log base 3 of 8x. And now what we can start doing, so we've just used basically this last property of logarithms and work backwards. We know the n is the coefficient. We can work the other way. We can work backward. And so we can do that. Now we're going to use some more of those definitions. So take these first two logarithms, same base, and we're adding them so we can express it as a single logarithm. Okay, so log base 3. But then we can multiply those two, 16 times y to the third power. We just took this property of logs and just went whoop this way. We can express it as a product. And then we have what we didn't touch. And then lastly, we can use the other property. We can, remember that if we are having a quotient, we can write it as a subtraction, or if we have a subtraction, we can write it as a quotient, and that's what we can do. So notice we have the same base, and we can keep log base 3. But now we can write this as a quotient. So 16 to the third power, 16y to the third power divided by 8x. And we took that crazy long logarithm and this whole big thing that we started with, and just wrote it as one single logarithm. How cool is that? Because it all works. We completely proved it. And so this whole long thing there is just, we can make it simple, which is what we've done. And now we can do the same thing for the second question, except we're going to work to expand. Okay, so now the second question is we're going to write this following logarithm, but we're going to put it in expanded. Okay, we're in expanded log form using those properties. So now we're going to start with something basic and then just blow it up. All right, so that's what we're going to do. We're going to take that basic thing and then just blow it up. We're going to expand as much as we possibly can using those properties that we have discovered to be true. So the first property that we could use is that exponent property, right? We have that exponent property, something raised to the power. We can move that exponent to be basically the coefficient for the logarithm. So we know this to be true, right? That's totally doable. And then here's where the trick comes in for this. If we start expanding what's happening, we have to be careful with that exponent or that coefficient. So now we can use the quotient property. Okay, so we know if this is the case, what does that mean we have? That means we have 3 log of 2 times the square root of x minus, and here's where we got to be careful, also 3 log, okay, so it's still there, also 3 log of 5. Okay, so we can take that. Is that true? Yeah, it's true. So 3 log of 5. Well, I almost messed up right there. Okay, so we have that to be the case. And now what we can do is expand it even further. Okay, so we have this situation here that's going on, and we can expand that because this is 2 times the square root of x, right? So 2 times the square root of x. So 3 log 2, right? And then using the property of the product property, that means we're adding 3 log times the square root of x, and then the minus 3 log 5 stays. Pardon this interruption.
Students, could I have your attention, please? Jaslyn Caballero. Jaslyn Caballero. Please come to student services.
She's famous now. She's on the video. Okay, so a student might look at this and say, we're done. We're totally done. And then I'd say, well, not quite, because we got something else going on here. Hopefully you see it. There's one more thing that we could do. We have another exponent to play with. You're thinking an exponent, you're kidding. Nope, not kidding, for real. Right there, that's the exponent. Isn't the square root of x x to the 1 half power? And why, yes it is. And so since that is x to the 1 half power, we can use that exponent property. Okay, so we have 3 log of x to the 1 half power. We could use that property then and bring that 1/2 over to the coefficient. So here's what we would actually have in the expansion. 3 log of 2 plus, now we have 3 times 1/2. Okay, so we have 3 times 1/2, or 3/2 log of x. And then minus 3 log of 5, right? And so that's how that would work. And we've completed, there's nothing else we could do. Some of you might be looking at this and thinking, well, can't we write it as a quotient? No, that's 3/2 is the coefficient. Okay, so the quotient property does not apply. Okay, so be careful here. The quotient property does not apply because this 3/2 is the coefficient, not here or here. So be careful there. Common mistake. So don't do that. I'll yell at you. Okay. So we have completely expanded. We took this little expression here and then wrote it as an expanded logarithm and then went crazy. Right? 3 log of 2 plus 3/2 log of x minus 3 log of 5, and then we've expanded the entire thing, and that is expanded logarithm form. How fun is that? Now, there's one other thing that we can do with properties of logs, and it's called the change of base formula. We could actually work to evaluate any logarithm using the change of base formula. So check this out. If you have any logarithm with any base, really, it doesn't matter what base it is. So take log base b of m. Okay, so it doesn't matter. Any logarithm with any base. You know what you can do? You can change the base formula. You can introduce a completely new base using this formula. You can invent a whole new base. We'll call it base c. So notice we're inventing an entirely new base. So we can have a new base, log base c of m, all of that over log base c, that same new base of the old base. Yeah, totally true. Totally true. So we could do that. All right, I'll basically use this last problem as an example of how it works. So let's take a look at number 3, and we're going to see this to be absolutely true. Now you can use your calculator for number 3, but I can't assess you on your knowledge of the change of base formula if you do that. So if I am assessing your knowledge of the change of base formula, and all you do is throw that in a calculator, I can't assess that. So try not to throw that in a calculator. We're going to use the change of base formula to evaluate that. Okay. So here's the deal. If we know that new change of base formula, we know this to be true, that the log base b of any logarithm is, look on the right, is log any new base. Okay, so we could break that up into using any new base. We have to think of what base would work for 16 and 32. So here's the main question. What would be a great base to use, a brand new base? What would be a smart new base? A smart new base we could use for both 32 and 16. Okay, this is going to be a question that's going to it's going to come back too. We're going to keep. This is a great question. I love this question. What would be a smart new base for both 32 and 16? Basically, what number could we use as a base that would yield a 32 and a 16, right? And you have to think. And could you think? Could we use 3? Could we use 4? Well, no. Hopefully, you're coming up with 2, right? So basically, what would be a great base for both 32 and 16 is base 2, right? So hopefully you've realized that. Base 2 would be a smart new base for both 32 and 16 because we know 2 to the 4th power is 16, 2 to the 5th power is 32. Isn't that a great new base, okay? Because we know 2 to the 4th power is 16, and we know 2 to the 5th power is 32. That means 2 is a great new base. All right, so we could use that new base with the change of base formula. Okay, so we can use that new base. So we know that new base now is going to be the c, right? That whole new base. So we have log base 16 of 32 could be equal to log base 2, right? This new base we're going to use, log base 2 of 32, all of that over log base 2 of 16. Okay, and we could use that change of base formula to help us out. Okay, so now what are we going to do? Okay, well, what can we do? We have in the numerator the log base 2 of 32. 2 to what power is 32? We know that to be 5. And then the denominator, 2 to what power is 16? We know that to be 4. So we could use the change of base formula to get to 5 over 4. And since I am assessing your knowledge of the change of base formula, make sure you're able to show the whole thing. Because again, you could totally use your calculator in case you're curious. We'll see how. Okay, so there's actually a button here somewhere. Oop, there it was. In the math button, you see it has log base, right? So you can have log base 16, right, of 32 equals 1.25, and then you can turn that into a fraction, right? Hey, 5 over 4. Okay, but if you do that, I can't assess your understanding of the change of base formula, and that's what I'm trying to do here. So make sure you're using the change of base formula. And that's it for the properties of logarithms. You're now in a great spot to get the homework done and practice, practice, practice. So thank you very much.